welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your class that has been the CBNST. In CBNST we have to start with class 6, and as you know that we had done class 5 here in the CBNST as well, where that is your computer based numerical and statistical technique that we have to cover up. In the last 5 classes we had even though started with the bisection method, and we are dealing with other question solving related to the bisection method as well. So here we're gonna start with the continuing that only. Before starting with this, it's a huge request to all the viewers to please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Other than bisection method, we had, even though I had told you in the last classes, the second method formula and as well as the regular falsing formula as well. But first we'll implement the bisection method fully, that you will be able to know about the questions as well, how you have to solve it out. After completing that, we'll start with the second method and respectively the regular falsy as well. So we'll go ahead for the first question of this session, but we had started with many of the question of bisection method in the last classes. Question is being, use bisection method to find the roots of the equation e to the power x minus 3x equals to 0. Correct to 3 places of decimal here. So we'll go ahead for the C. Use bisection method to find the roots of the equation e to the power x minus 3x equals to 0. Correct to 3 decimal places. So we'll go ahead for the solution here as well. So here what we'll have here, fx e to the power x minus 3x equals to 0. So to establish an initial interval, we'll put x equals to 0, so f0 equals to e0 minus 3 into 0, which is equals to 1. Then we'll put 1 e power 1 minus 3 into 1, which is equals to minus 0.281718, that we have as an answer as well. So here you have to note that here f of 0, as I told you in the last class, f of 1 is less than 0. So hence the root lies in a comma b is equals to 0 comma 1. In order to reduce the number of iteration fa and fb, that should be close to 0, and at the same time fa fb is less than 0. Hence let us check fx for the following different values as well. We'll check it for f 0.4, x 0.5, e 0.5 minus 3 into 0.5 equals to 0.148721, or rather we have here f 0.6 equals to e 0.6 minus 3 into 0.6 equals to 0.022. In the same case 0.00, that is we have 022119, so f 0.65 is equals to e to the power 0.65 minus 3 into 0.65 equals to minus 0.034459. Here value of x are taken such that fx remains close to 0, since we have 0.6, f 0.65 is less than 0. Root lies in a comma b equals to 0.6, 0.65. So for iteration 1, For that, a plus b by 2 0.6 plus 0.65 0.625 0.625 equals to 0.625 minus 3 into 0.625 equals to 0.006754. Since f 0.6 that is into f 0.625 less than 0, root lies in a comma b equals to 0.625 that we have. We'll go ahead for the next iteration 1. After completing iteration 1, we have iteration 2. A plus b by 2 equals to 0.6 plus 0.625 upon 2 equals to 0.6125. This is we have, so f 0.6125 equals to e power 0.6125 minus 3 into 0.6125 equals to 0.007538 we have, since f 0.6125 multiplied 0.625 less than 0, so root lies in a comma b. We have your value 0.6125 and 0.625. So here you have to note that the latest value of a and b that should be taken to check if a and if b is less than 0. Now we check for iteration 3 here. Iteration 3. So for the iteration 3 we have a plus b by 2 equals to 0.6125 plus 0.625 upon 2 is equals to 0.61875. So f of 0.61875 equals to e power 0.61875 minus 3 into 0.61875, and that is being equals to 0.000356 here. Since f 0.61875 multiply f 0.625 less than 0, so root lies in a comma b, and that is being equals to 0.6. For the 6 we have 61875, 0.625 we have. Now we talk for the iteration 4 here. That is of course being important one as well, and that even though we have to talk about it. So for that, iteration 4, which is a plus b by 2 0.61875 plus 0.625 upon 2 equals to 0.621875. We have for f 0.621875 equals to e power 0.61621 minus 3 into 0.621875, which is equals to minus 0.003208 here. So here for that, since f 0.61875 into f 0.621875 is less than 0. So root lies in a comma b is equals to 0.62 61875 and 0.621875 here. We'll go ahead for iteration 5. We talk about it. Of course, that has been important one here. So iteration 5. For iteration 5, it is a plus b by 2. 0.61875 plus 0.621875 upon 2 is equals to 0.620313. So f of 0, which we have here 0.620313, e की power 0.620313 equals to minus 3 into 0.620313, which will give 0.001428. On the same cases, for since f 0.61875 multiply f 0.620313 less than 0, so root lies in a comma b, so that is being equals to 0.61875 comma 0.620313 that we have here. So this is for iteration 5. Now we'll go ahead for iteration 6 as well, and further we'll discuss about iteration 7. So we have to do the iteration 7 in this. We'll go ahead for the same, then we'll do it another question here. So we'll go ahead for iteration 6 here, that is being as follows, and that what we have to discuss here as well. So we talk about the iteration that we have, iteration 5 we have, and for the same we go ahead and we'll even though had find it out for the iteration 5 here. Now we'll go ahead for the iteration that will be the iteration 6, and which is being as follows here for the same. So iteration 6, that we have a plus b by 2 equals to 0.61875 plus 0.620313 whole upon 2, which is equals to 0.619531. So 0 point that we have here 0.6 here. On the same cases, we'll go ahead here, which has been f 0.619531 equals to e power 0.61951 minus 3 into 0.61951 is equals to minus 0.000537 we have. Now we'll go ahead for since that the condition will be following here. So since f 0.61875, f 0.619531 is less than 0, so root lies in a comma b equals to, which has been the roots we have here, is 0.61875 comma 0.619531 we have. So now we'll talk about the iteration 7 as well, so that is when we have to talk about it. Iteration 7 we have. For the same, it is a plus b by 2 equals to 0.61875 plus 0.619531 upon 2, and that is being equals to value 0.619141 that we have. So here observe that the value of the root is repeating up to 3 places of decimal in 6th and 7th iteration, and here x equals to 0.619141 is the root of fx, correct to the 3 decimal places as well. We'll go ahead to find out the another question here, which is being the next question. The question we have here is you have to use bisection method to determine the roots of, and here that is being the fx equals to e power minus x is equals to 0, which we have to do. Go ahead, use bisection method to determine the root of, so fx equals to e power minus x equals to 0. So we have to find out to this as well. To obtain an interval a comma b in which root lies, let f of 0 equals to e की power 0 minus 0 equals to 1. Then we put 1 here, f of 1 e की power minus 1 equals to minus 0.6321205. So since f of 0 and f of 1 is less than 0, root lies in 0, 1 we have here. For further we talk about it, for further even though we have to solve it out as well. For the iterations we have here, that is to be as follows as well. So on the same cases we go ahead, and for the iteration 1 we have to solve like that only, a plus b by whole 2, and that has been of course important one here. And so let's go ahead for the same, so which is being for iteration 1. It is a plus b by 2 equals to 0 plus 1 by 2 equals to 0.5. So f 0.5 equals to 0.1065306. For f of 0 it is equals to 1, and f of 1 equals to minus 0.6321205. So since f 0.5 multiply f of 1 is less than 0, root lies in a comma b equals to 0.5 comma 1 here. Now for iteration 2 we talk about it. For iteration 2 we have, which has been a plus b by 2, 0.5 plus 1 upon 2, first to 0.75. So for f 0.75 equals to minus 0.10776334. For f of 0.5 equals to 0.1065306, and for f of 1 equals to minus 0.6321205. Since 0.5 f 0.75 equals to 0, so root lies in a comma b equals to 0.5 and 0.75 here. We'll go ahead for iteration 3rd here as well. So iteration 3 we go ahead here, and which has been important for as well. So that has been your iteration 3rd. For iteration 3rd, it is a plus b by 2 equals to 0.5 plus 0.75.2, which is equal to 0.625. So f of 0.625 equals to minus 0.0897385. For f of 0.5 we have is equals to 0.1065306, and f of 0.75 equals to minus 0.2776334. Since f 0.5 and f 0.625 is less than 0, root lies in a comma b equals to 0.5 and 0.625 here. We go ahead for the next iteration here. So we go ahead for the iteration 4 here. In iteration 4, it will be your a plus b by 2 equals to 0.5 plus 0.625 upon 2 equals to 0.5625. So f of 0.5625 equals to 0.00072828, and your f of 0.5 we have it's equals to 0.1065306, and f of 0.625 equals to minus 0.0897385 we have. So here, since for that roots we'll talk about it. Since f 0.5625 and f 0.625 is less than 0, so root lies in a comma b, which is of course equals to 0.5625 and 0.625 here. So with the same cases here, similarly the next iteration can be performed by the following. That will make a table as cost, that list out of the calculations here as well, which will be a longer but yes, we will have to make it. So of course we will make it out here as well, but here we'll made it in the next coming class, so that it will be improved here only. That will be when you are going ahead for the solution, it will make and helpful for that as well. So here we're gonna end up with this, and it's a huge request to all the viewers to please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Other than this, if I'm going ahead here in the detail about it, there are many topics that we have to cover up, and we'll discuss one by one. Of course, after completing the bisection method, we'll start discussing about second method, and then we'll regular falsy will do it that as well. And there are many more that we have to cover up. Here we're going to end up with, and other than this, if I'm talking about the computer based numerical and statistical technique, we had done your sociology and software engineering, and in chemistry we had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 as well. After talking about that as well, yes, we had done many of the topics which has been in the form of, we had done your understanding the human being comprehensively, the human aspiration and its fulfillment. And after talking about that, yes, we had done many of the topics, like we had done your yeah, we are dealing with your diagram, that has been important for you all, and that we are dealing with that has been your English vocabulary, which enhance your English and communication skill as well. We are dealing with the quantitative aptitude. In arithmetical ability, we had done operations on numbers, LCM and SF of numbers, decimal fraction, simplifications, square roots and cube roots, problems on numbers, problems on ages, sorts and indices, and percentage we are dealing here as well. After talking about that, as here, yes, we had done your In terms of reasoning, we had done your which is been your verbal reasoning. In that, we had done general mental ability in the logic reasoning. In non-verbal reasoning, we had done your series and logic classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, fluid detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation, analysis, and practice question set that we had done here. Other than this, we talk about in the computer-based numerical and statistical technique, where we are covering it unit 1, which is in the long unit, and that is in the computer arithmetic errors, rules of equation. In computer arithmetic error, we had done your floating point arithmetic, machine epsilon, round off error, chopping error, truncation error, associative and distributive law, and a floating point arithmetic, inherent error propagation, numerical instability. In rules of equation, we had done your second. We are dealing with second method, Newton-Raphson method, and a fixed point iteration method for a simple rules of derivation of the rate of the convergence, Atkinson's accelerations of convergence, modified Newton-Raphson method for multiple roots, a Bridge-White method for the polynomial, and Bairstow method for the quadratic factor computer algorithm, and of these method as well. In unit 2, we will have to discuss about the interpolation, which has been the algorithm and the error analysis of the Lagrange and the Newton. That is your dividend differences interpolation relationship in various difference operation, that is the piecewise linear interpolation, cubic spline interpolation, natural spline, and then we have to done with the Chekhov polynomial approximation, and your Lang-Cos economizations of the power series. In computing, we had done your linear and non-linear least square approximation, third, and conditioning in the least square method, Gram-Schmidt process of orthogonalization, computer algorithm of least square curve fitting as well. On unit third is your differentiation integration. In that, we have to cover up the methods based on interpolations and the finite difference, Richard's extrapolations integration. In that, we have to cover up the error analysis of trapezoidal and Simpson method, Newton's Coase integration method, Gaussian's integration method, Gauss-Legrand method, and Lobato integration method, and Rodau integration method. Error terms in the integration method as well. After talking about that as well, yes, we had done many of the topics in terms of it, and that what again have to even to discuss about it, and which is all about your unit 4, which is in the solution of the simultaneous linear algebraic equation. Here we have to cover up the Gauss elimination method, conditional systems, condition number, successive over the relaxation method, rate of the conversion, solution of the ordinary differential equation. We have to cover up the single step method, Range-Kutta second order, third order, fourth order method, multi-step method, predicator corrector method, and statistical technique. We have to cover up the statistical hypothesis, test of hypothesis, type 1, type 2 error, level of the significance test involving and that normal distribution as well. So here we're gonna end up with, and it's a huge request to all the viewers to please go through with the subscribe button, and please like, share, and subscribe our channel so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Other than this, we are dealing with many more of the topics that we have to cover up of course, and that will be improving your CBNST, and that is your improving whatever the we will be uploading you. What is required of you, you can just tell me, and we will surely be starting with your that has been your PCB questions, of course physics, chemistry, biology questions that has been asked here in the competition paper, that we will have to discuss of course, and the facts about the countries that we will surely be discussing about in the next coming classes. So stay tuned with us, and please go ahead with like, share, and subscribe our channel. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.